All right, well, good morning, everyone. My name is Katie Edmond, and today I'll be discussing the Public Land Renewable Energy Development Act of 2013. Before I get started, I'd like to first thank my output team members, Marielle, Brittany, and Bora, as well as our faculty advisor, Professor Callahan, my fellow manager, Mara, and the rest of my workshop team with whom it's been a pleasure to work all summer. So today, I'll begin by giving a very brief overview of the bill itself, followed by a description of the problem this bill is attempting to address, as well as the solutions that the bill proposes to address those problems. I'll also discuss a little bit about how to evaluate the success of this bill and some issues and controversies related to the solutions proposed in the legislation. Essentially, the Public Land Renewable Energy Development Act of 2013 is seeking to encourage the production of solar and wind energy on public lands. Now, why do we want to produce solar and wind on public lands? At present, the United States produces the vast majority of its energy supply as a result of fossil fuel combustion. In 2010, approximately 78% of U.S. energy production came from the combustion of coal, natural gas, and crude oil. Now, the extraction of these fossil fuels causes local environmental degradation, and the combustion of these fuel sources contributes to global climate change. To begin on the local level, when these resources are extracted from the earth, it is incredibly destructive to the surrounding environment. In addition to the removal of sediment above the resource itself, service roads have to be constructed and heavy machinery must be used, all of which contributes to the destruction, disruption, and fragmentation of wildlife habitat and a loss of biodiversity. Additionally, there's also some soil erosion concerns as well as water contamination issues. Now, the Bureau of Land Management does recommend best management practices for projects conducted on its lands, but these practices reduce but do not eliminate the environmental impacts associated with the extraction of fossil fuels. Once those fuels are removed from the earth, they are burned to be used to produce electricity. The combustion of the fossil fuels releases carbon dioxide gas, or CO2, into the atmosphere. In the atmosphere, CO2 and other greenhouse gases trap radiation that would ordinarily be lost to space, which results in an overall increase in global average temperatures. This temperature increase has a significant impact on global climate systems. Some observed and projected effects of this global climate change include sea level rise, more frequent and intense precipitation events, increased flooding, as well as increased rates of disease and longer droughts. The United States produces 20% of global carbon emissions, and approximately 84% of our current CO2 emissions are energy related. So, in order to mitigate these local environmental impacts associated with the extraction of fossil fuels and the global effects associated with carbon emissions, the Public Land Renewable Energy Development Act seeks to encourage the production of renewable energy on public lands. The bill will go about this by identifying lands that are suitable for solar and wind energy production on lands managed by the Bureau of Land Management, the U.S. Forest Service, and the military. It will establish a total of 4 pilot programs on these lands, 2 for solar and 2 for wind, as well as establishing a competitive leasing structure similar to the one that's currently used for conventional fuel sources. And a portion of these lease revenues will go toward the creation of a renewable energy resource conservation fund, which I'll discuss in more detail in just a moment. So, how will we know if this bill is working? There are a few ways that we can evaluate the success of the bill. Firstly, if the policies put forth mitigate the environmental impacts associated with energy production. This legislation requires that programmatic environmental impact statements be conducted on all potential project lands. These statements will help identify and protect species and areas that are most at risk, as well as design management practices for the project areas. As I mentioned before, a portion of the lease revenues will go toward the creation of a renewable energy resource conservation fund, which will be used by regions affected by wind and solar production to address and offset the impacts of utility-scale renewable energy development on federal lands. We can also address how effectively this bill is able to diversify the United States energy supply and make renewable energies a more feasible alternative to fossil fuel usage. The bill facilitates the process for siting, reviewing, and installing solar and wind projects on public lands, and again, expands the competitive leasing structure on all suitable lands managed by the Bureau of Land Management, the Forest Service, and military lands. Finally, since 1/3 of the U.S.'s CO2 emissions currently come from electricity production, displacing CO2 emitting fossil fuels with solar and wind energy will theoretically reduce the United States' CO2 emissions. Wind and solar currently account for the reduction of about 100 million tons of CO2. Now, all that said, these are not perfect solutions to the problems I've already outlined. There are still a number of issues and controversies related to these solutions, including ecological impacts, reliability, and concerns over transmission and storage. I'll start by discussing the ecological impacts of solar and wind production. The image on the left is of the Ivanpah Solar Electric Generating System in California's Mojave Desert. When construction is completed, Ivanpah will be the largest solar power tower system in the world. The entire project site encompasses about 4,000 acres. Such a large footprint, as you can imagine, displaces a number of plant and animal species, including the desert tortoise, which is a threatened and protected species under the Endangered Species Act. There are also wildlife concerns associated with wind power production, specifically the mortality level of birds and bats that collide with the blades and towers of functioning wind turbines. Such mortality rates can be reduced through careful environmental siting, for example, ensuring that turbines are not placed within migratory corridors and that blade designs are used that are most visible to birds and bats. The second major issue is the inherent variability of solar and wind as energy sources. As we all know, the wind doesn't always blow and the sun doesn't always shine. Shown here is a graph of wind energy output from a wind farm in California over the hours of a day. Each colored line represents a different day. As you can probably tell, there's no discernible or predictable pattern to how much energy will be produced, which makes management of such a resource incredibly difficult. You may also note that there are frequently days, such as day 29, which is, I'll use the cursor, shown here, where the highest energy output does not coincide with the time of highest energy demand. Not many people are demanding a lot of energy around 3 to 5 o'clock in the morning. So a natural solution to such a problem is to store the energy generated so that it can be used at a time where there is higher demand. At this time, there are many storage technologies available, but unfortunately they're yet to be commercialized and so can still be prohibitively expensive for use on a utility scale. Additionally, because most solar and wind projects are geographically remote, the energy they produce has to be transmitted to areas where the energy is being demanded. A World Resource Institute report estimated that 30 to 40,000 miles of new transmission lines will be required by 2030 just to support the renewable portfolio standards that have already been adopted by 31 different states. So this is certainly an issue that will need to be addressed as solar and wind energy production are expanded on federal lands. So to review, the Public Land Renewable Energy Development Act of 2013 is seeking to encourage the production of solar and wind energy on public lands because our current use of fossil fuels as a resource damages the local environment through its extraction, contributes to global climate change through its combustion. So the bill will go about addressing these issues by instituting a process, streamlining the process for solar and wind energy production on public lands, and creating a renewable energy resource conservation fund to protect the environment. We can evaluate success based on how successfully it is able to protect the environment and mitigate the environmental impacts associated with solar and wind production, as well as how well it is able to make solar and wind feasible alternatives to fossil fuels and the reduction of carbon dioxide emissions. Naturally, there are still some concerns, including environmental impacts of the new renewable technologies, the reliability of energy production, and the transmission and storage of energy. But with hope, with careful environmental siting and review, this bill can be the first step on the path to a more cleaner, energy efficient future. Now, I'd like to thank you for your time, and if you have any questions, I'd be happy to answer them. Thank you.
Hi, good job. I was wondering, I know this semester was science focused, but I was wondering if any of the controversies you came across had to do with community backlash of using these public lands that haven't.
Yeah, I know that was something that you guys addressed in your presentation. It wasn't as big a focus because we were specifically focused on how on the energy production process itself as opposed to the installation process. And there's slightly less community backlash because these are proposed on public lands. The biggest thing was to ensure that there is still recreational access to some of these federally managed areas and preserving that. But as far as there isn't as much private community backlash for these public land projects.
Hi. As far as I'm concerned, the renewable energy generation only accounts for a very small amount of the energy usage throughout the country. So I'm just curious about how much your bill can contribute to solve those environmental problems.
That's a great question. It is something that we struggled with a little bit over the semester, because there's a lot of different factors that go into actually predicting how much energy can be produced. For example, do we cover every inch of the desert with solar panels? Do we cover every square foot of North Dakota with wind turbines? There are a lot of different things to consider that can affect the megawatt production of these renewable energy technologies. And we have some numbers that I'm more than happy to look up for you over the break as well.
Hi, Katie. Great job.
Thank you.
I'm very impressed. I'm curious, the lands that you talked about from the Bureau of Land Management, are any of them intersecting with Native American reservations?
No, I don't believe so.
Okay. I'm just curious because Native American reservations are treated as tribal sovereignty in the U.S., so they would have to create a federal or a treaty as if they were doing a treaty with Japan.
So they are not considered as part of this project.
Okay.
They would not be considered a suitable project area under this bill.
Cool. Thanks.
Great. Thank you so much.